Good evening, class. It's another opportunity for me to start the second class for this course, about 304, General Ecology. It's a great opportunity that see your audience to join me in this class. Last week, I had a brief class. Oh, someone has just joined. Okay. Oh, Mr. Daniel. Good evening, sir. Okay. Mr. Daniel is about joining us. He's trying to hook up to the class. Mr. Daniel, welcome to our class. It's nice, nice to have you. All right, I think you're trying to connect with us. No problem. So like I said, today we are on topic 2 of this course, which has to do with the cycling of nutrients in the ecosystem. The cycling of nutrients in the ecosystem. What we'll be looking at, we're going to look at the different cycling, water cycle, carbon cycle, the nitrogen cycle. The nitrogen cycle is more complex as compared to other cycles that are quite straightforward, because it's broken down into 5 stages, where we have the ammonification, the nitrification, the uptake of nitrogen by plant, nitrogen fixation, denitrification. I'll also be considering the phosphorus cycle and how these different cycles interact with each other. Okay. So Daniel, I hope you can hear me. I hope you can hear me, Mr. Daniel.
Yes, please, I can hear you. Thank you, sir.
Welcome to the class, sir.
Thank you, sir.
You couldn't join me last week. I think you didn't get the...
I couldn't get the, I was trying to, I thought it was going to be on e-learn. So I was just trying to connect, but it didn't go. But now I got it now.
Okay, all right, you're welcome, please.
Thank you, sir.
All right. I don't want to waste much time. I had a PowerPoint which I want to share. Just a summary of what we are to do. Okay. Right. I hope you can see what I'm doing right now.
Yes, I can. Yeah.
Okay. Just want to start sharing. Right. Okay. All right. That was an old record that we did last semester, so I've not updated it. But then we still have the PowerPoint that goes on to
Okay.
it. So that's why I forget, because if you notice it talks about student missing 2 classes already, but already we've missed 1. So it's the second topic that we're looking at, which is the cycling of nutrient. My name still remains Dr. Senawo Imekupete. You can get me at imesenawo@gmail.com. Introduction. We all know that there is always interaction, organisms with their surrounding. And some of these interactions are positive or either negative. Then you must also know that these biotic factors or nutrients or substances that we find in the environment have what they call processes. Processes in the sense that they keep on recycling themselves over time. And that is what we term as biogeochemical cycle, which implies that all substances that we see in the environment occur through a cycling path which includes both biological and chemical processes. But then, organisms, as we know, cannot exist without some of these substances or nutrients. It's just like oxygen that we breathe. Without oxygen, it will be impossible for humans to survive. And other nutrients too. Are you with me, Mr. Daniel? Please, can you unmute yourself?
Okay.
All right.
I am.
The
network just
my brother,
it's just going up and down.
That's the unfortunate thing we have here. Seriously, it's been going up and down. But
Yeah.
let's see what we can quickly do before it goes off again. So what I've said was that these nutrients that exist in our surrounding, in our environment, are very important for the existence of both plant and animal. We can't do without them. So, and I hope you can see the screenshot.
Yes, yeah, I do.
Okay. So I've highlighted some of these nutrients like carbon, nitrogen, oxygen, phosphorus, potassium, sulfur, magnesium, calcium, sodium. Yeah. Although there are some of them that are very necessary in small amounts that plants need. I know out of all of these, the ones that are peculiar to us is oxygen, isn't it?
Exactly.
Oxygen. There's nothing we need to do with carbon. That's to plant. Nitrogen, same to plant. Phosphorus, same to plant. Potassium, sulfur, magnesium, calcium, sodium, iron, even though we may need small amount of iron, but it's not that significant. It's about 0.00 whatever. So it's not significant. Yep. And we can get iron from plant, not just from, the soil or whatever. Mm-hmm. So these are the different nutrients that exist, which undergo cycling paths, both biological and chemical. Now, the next slide, it's just a simple chart. To show this cycling. I'll just have to put the two out of all that we mentioned.
Okay.
the one on your right hand side, as you can see the sun, where the plant traps the sun, manufacture their food, green plant. As they do that, they grow. And what do we see? Herbivores that feed some plants become the consumer. Herbivores feeds on this plant. You can see the arrow. And each stages, as we can see on that chart, shows that there is something that is given out, which is heat. You can see an arrow that shows heat generated. That is ATP that is generated. Same after herbivores, some of them will die, becoming dead organisms or dead plant, and they become decomposed matter. As these stages, there's also heat that is released. They become non-living components in the soil as they decompose. And these non-living components can be taken up by the plant because they are in the soil. That's why you can see a very simple chart to show this biogeochemical cycle. On the other side, you see the water cycle.
Okay.
Yeah, you see the solar energy, which is on the yellow color. As it builds up, because before the cloud gets heavy, there is a process of evaporation and transpiration. You know the difference between evaporation and transpiration? As you can see, there's a transpiration and evaporation. There's always a difference because the other one is true plant. The water that goes to the atmosphere, it's true plant. As you can see the arrow and the green, whatever there. Whereas the other one is direct from the water body. It could be from the ocean, it could be from the lakes, it could be from the stream, evaporating to the atmosphere. And when it becomes heavy and condensed, water falls as precipitation back to the earth. You can see what they call percolation in soil. Some of this water body goes into the soil and form what we call the underground water. There are some of this underground water that can also, move out and can be leached down to the ocean. There's some books that will show those details. So this is just a simple chart that shows a simple nutrient cycle that can be found or can be noted in the environment. Next was a class activity question that was asked. Nitrogen, as we know, it's abundant around us. Very about something percent of it is noted to be found around us. But then, even though it's so abundant, it's not as easy as you can think for us to trap these nutrients. Not easy to trap this nutrient. So something is required for nitrogen to be trapped. So the question is, what is the primary reservoir of nitrogen? Assuming you've gone through your notes, that was a question that I did ask. What is the primary reservoir of nitrogen?
I think nitrogen is, you have not got to the note really, but I think that nitrogen reservoir is in the plants.
Okay.
Plant is reservoir for nitrogen.
Okay. Thank you for your answer. Well, actually, it's not in plant. Even though plant use it, as we know, the primary reservoir of nitrogen is the atmosphere. It's one of the major component of gas that is found in the atmosphere. It's about 78%. out of all the total 100% of gases we have. So let's say almost 80% of nitrogen is found as gas constituents in the atmosphere. But then, even though it's so much, plant cannot use nitrogen directly like that. Okay. It's not possible. So it has to be broken down into stages, about 5 stages of it, that the nitrogen needs to be broken down. There's what they call ammonification process. Okay. Ammonification process. This process, nitrogen is converted into ammonia ion by the action of a fungi or bacteria. That's the first stage.
In the soil, is it?
Yes. Okay. It's converted into ammonia ion. Yeah.
Okay.
Want to ask us?
Sorry, sir. I want to ask. The nitrogen is present in the air.
Yeah.
Does that mean that it's come back to the soil as a result of because of rain, or how does it get to the soil where the ammonification will take place?
Okay, that's a good question. It's during when there's always a strike, thunder strike, as you know, and during that process,
okay,
it gets to the soil. When it gets to the soil, the fungi or the bacteria now break it, because the fact is, as it is in the soil, plant cannot absorb the nitrogen as its component. So it has to be broken down. And that is the process as we know as ammonification. Are we together?
Okay, sir. So yes, sir. I just want to know, is it when this thundering occurs in the atmosphere and
lightning strike?
Is it the process? Okay, strike. Okay, is it that process? It just came down, or there must be rain before it will be watered or through water?
Yes,
before? How
it
does
has to. Yeah, it has to be rain. Yeah.
Okay.
All right. So after ammonification, that's what we call as nitrification. Nitrification. It's just a process of bacteria performing some reaction on the ammonium that has been formed during the process of ammonification. And this will oxidize this ammonia to form what we know as nitrate. Are we together? The bacteria, there are so many of these bacteria. So what the bacteria does is to convert this ammonium to nitrate. We have Nitrosomonas, Nitrocephaly, Nitrosococcus, yeah, and I'm just trying to remember some of them. It's about 4 of these bacteria that act on the conversion. But it doesn't end there, because there are about 2 stages of nitrification. It will convert ammonia to nitrite, and the next will now convert it to nitrate by another group of bacteria. So we have 2 sets of bacteria, ammonia to nitrite and nitrite to nitrate.
Okay.
But ammonia to nitrite, it's about 4 bacteria that are involved: Nitrosomonas, Nitrososphaera, Nitrosococcus, and Nitrosolubus. That's the 4 bacteria. Now, 3 bacteria are involved in converting this nitrite that has been formed in the soil to nitrate, and they are called Nitrobacter, Nitrosphaera, and Nitrococcus.
Okay.
Yeah. So when that is done, the next stage, nitrate cannot be uptaken, cannot be absorbed by plant.
Okay, so the plant absorb nitrates.
Yes.
Okay.
Now,
sorry, sir, please. The conversion of, please, can you start from ammonification?
Okay.
So, let me just.
Okay. So what I said about ammonification is that sometimes, apart from the fact that the nitrogen in the atmosphere could be converted and we could find them in the soil, there are some organisms too. You want to write it down? Hello? Hello, Mr. Daniel. Hello? 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 All right. So, like I said, the nitrate that has been formed, most plants will now absorb this into their system, and then after that we have what they call nitrogen fixation, the graduation of the atmospheric nitrogen to ammonia ion. So great importance to organisms together with lightning, natural way in which organisms gain access to the huge reservoir nitrogen that can only be carried out by certain species of bacteria, which are the cyanobacteria. Some of these species are free living, occurring in water. Others exist in symbiotic relationship with higher plants. The most known of them is Rhizobium, as we know, which is a nitrogen fixing bacteria. So, nitrification. Mr. Daniel. Hello. Hello, Mr. Daniel. Hello. Hello.
Okay. Okay.
Oh, your
Can you hear me
network.
now, sir?
Yeah, I can hear you. So.
Hello.
All right. So we're looking
Yes,
at
it's the network.
you were yeah,
Okay,
so that you left off. I said apart from the fact that the nitrogen in the air can be converted through lightning, like I said, there are other sources which are from organisms that excrete nitrogenous waste. Are we together? They
okay.
excrete nitrogenous waste. And so when they die, this nitrogen, when they die, this nitrogen will be converted that is in the soil, because these organisms have them in their waste. They can now be converted to what we know as ammonification, which is the first stage. And that is done by a fungi or bacteria. Now, ammonification now, there are two stages that is involved in this, which leads to nitrification. The ammonium that is formed from ammonification will now be oxidized by 4 bacteria. And when we talk about oxidation, you usually remember your chemistry in your secondary school. It's a reaction process. So it will now oxidize this ammonium to form what we know as the nitrite. And I mentioned 4 bacteria: Nitrosomonas, Nitrosophila, Nitrosococcus, and Nitrosolobos. And I said, at nitrites, it does not end there, because plant cannot take nitrite. It can only take nitrate. So needs to be oxidized. Hello, sir. Hello. All right, let me move on. It needs to be oxidized by 3 different bacteria: Nitrobacter, Nitrosophila, and Nitrococcus, to form nitrate. And these will be taken up by plant. These will be absorbed by plant. Hello, are you back, sir?
Yes, I am back. I'm back. Yeah, in fact, the network here is
Okay, I
only giving
understand.
me problem.
So where are you actually residing,
Okay.
sir?
I'm in Lagos.
Okay. Oh, that should have been better network over there. I'm in New York right now, so I think Lagos should have been having a better network. Except maybe Monday seems okay, Tuesday, because it's evening. It may be peak period for calls and messages, so it will be jammed.
Yes. I think that's the issue.
Okay. No, what
But
will
or
happen?
maybe the no,
Yeah, I'm hearing you, sir.
I think still maybe location, but
Okay.
I came to this area because network here has been good. But what I'm seeing now is like it's
Which part?
somehow.
Which
I
side
think
of
generally
Lagos?
in Lagos, the network here has been Yaba.
Okay, Yaba should be better now. Yaba should have a very good network.
Yeah, it's better. That's why. Yes, but I just don't know why it is going up and down. You know, I've
Okay.
changed from MTN to Etisalat, and it's still almost the same thing. Okay, let's go on, sir.
It's the peak period. I think that's the problem. 7 o'clock, that's when people
Yes.
make calls, other activity.
Mm-hmm.
So like I said, don't worry, I'll make a video of the slides and upload on the page later on. So just see what we can quickly do.
Oh, okay.
Let's see what we can quickly do with other. So we were talking about this other one, what do they call it? Nitrogen.
The other source
Phosphorus.
of nitrogen, yes.
Yeah. So, okay, the other source, which was
Nitrogen, yes.
Nitrogenous waste could be from animals, and the other one was from atmosphere. It's just two ways, but it's just that when it gets to the soil, they need to be converted to a form that the plant can use. It's very important for plant growth and survival. Without them and without these substances, it's just like oxygen that is so important to us too. So let's look at phosphorus. Although just like other nutrients that we've talked about, one thing with phosphorus is that it's not found in the atmosphere. It's not like carbon, it's not like nitrogen, it's not like oxygen that we can get in the atmosphere. But whereas phosphorus can only be found in the rock. So it has to be broken down. It has to be broken down or undergo reduction processes so that the plants can take these substances. Although they are very short in supply, but then a few ones that are necessary can also affect plant growth. Yes, can affect plant growth. It is noted that they limit plant growth. Phosphorus limit plant growth. That's the research that has been done. But they've been used in other aspects of life. They've been modified, like phosphate-rich rock found as have been converted to fertilizer to help plants to grow. So it means that they've been synthesized to a form that can aid agricultural growth. Now, interactions between these nutrients is what we want to look at now. The burning of fossil fuel, for example, not only put large amounts of carbon into the atmosphere, it also increased the amount of atmospheric oxygen, phosphorus, and sulfur. Yes, that's what these things do. And the interdependency of this nutrient is obvious when one considers nutrient cycling through organism. What we're trying to say is that one, no matter how you say one is important, all of these nutrients are independent, are all linked together. Nobody will say without me, you can't survive. No, not at all. So they all link so as to, complete these nutrient cycle that is very important to organism, both aquatic and also terrestrial. So carbon, nitrogen, phosphorus, oxygen, calcium, potassium, chloride are all found and are very important in organisms. So when herbivores eat a plant or a carnivore, an animal, it ingests at one and not just carbon, all other things that we can see in living organisms. I think I have another short question. Now, the question is, list the elements that have liquid reservoir. List the elements that have liquid reservoir. So you said that you've not gone through your notes. It will be difficult for, yeah. Okay.
The element that have liquid reservoir. Sorry, the question, is it the element that are found in liquid reservoir?
Yes.
Okay. Oxygen.
Yeah, oxygen. Yeah. What else?
Oxygen. Nitrogen is in the soil. Phosphorus.
Rock. That's not a liquid, that's a solid. That's a solid reservoir. What about water? I forgot to mention water.
Okay, the network just
yeah. So as I said,
me out.
You mentioned phosphorus.
It's always
sorry. I
okay,
said you mentioned.
Are you hearing me now, sir?
I'm hearing you very well, sir. So you mentioned phosphorus. I said phosphorus is. Hello, I'm hearing you, sir. I'm hearing you very clear.
Okay.
So I said you mentioned phosphorus, and I said phosphorus is in solid, is in rock, not liquid. It's in rock. And I said
yes,
water.
I said
water.
Okay. Water. I said phosphorus is a rock. Okay.
Yes.
Okay. I know.
Network is bad. All right. Let me just make a summary of what you're just coming in and doing. Actually, yeah. Today we have looked at the importance of nutrients because they are very critical to the lives of organisms within an ecosystem. Hello, Mr. Daniel, are you with me? Hello, Mr. Daniel.
Okay, yes, I'm here now. The network is just up and down.
Let me just make a summary of what
I said.
I just want to make a summary. Don't worry, I will include all those things now. So just because we don't know when network will go up again. So like I said this evening we'll look at the importance nutrients, and we'll be able to know that they are very critical to the lives of organisms. And we mentioned water, we mentioned nitrogen, phosphorus. Oxygen is also there. They are very important. Without them, I don't think there will be any life form here on Earth. And unlike the flow of energy that exists in living organisms, all nutrients used in an ecosystem operate on a closed system. All the nutrients that we talk about, they operate on a closed system. That is, they have their parts. They are not just, scattered. They're not just scattered, they have a part. And that is why they are being recycled within organism in the system over and over again. If a system that is not closed, it means that some of these things will be loose out. And before you can get them back, the process. But since they are closed, they've been maintained over time. The percentage of some of these nutrients, like in the air, in the water, are always very constant. You understand me? They are very constant over time, so they've not changed.
Yes.
Except maybe human activity, just like what people are complaining about global warming of these, that has been as a result of human activity, which we know. So we also talk about the fact that the sources of these nutrients, carbon, nitrogen, and oxygen, they both have gaseous or liquid reservoir, just as water. So it means that you can see them in gaseous form, or you can see them in liquid form. Except phosphorus, as we know, have solid reservoir. They can be found in the rock. The carbon cycle is very unusual among all nutrient cycle. Why? Because it does not involve a decomposer. Yeah, you don't need a decomposer to break this cycle down. Whereas like nitrogen, it's very complex. It's the most complex of all nutrient cycle that we have because of the stages and also the bacteria, the fungi that are involved in breaking them down. For phosphorus, they are insoluble, as we said, they are solid, and they are in small amounts. They are not as abundant as other nutrients that we have. So they are very scarce, and their absence limit plant growth. So they are just needed in small amounts of none. So that's why sometimes a land that don't have a phosphorus or phosphate, don't say phosphorus because it needs to be converted to be phosphate. That's what the plant would now use. So that's why you see some fertilizer will contain phosphate or superphosphate, which boosts agricultural crops. And as I was ending it too, I also said that there's no nutrient that says I can stand on my own. Everybody have relationship. They are connected together in this circle. And that's why we know them as biogeochemical circle. So that's just a brief summary of what we supposed to do today. As usual, thank you so much. And as we are told to do, we have to play the
Okay, thank you very much, sir.
All right. So what will happen? I'll do the recording. What I'll do is I will do the recording of this PowerPoint and put it on my online facilitation, so that in case you want to still get the details, you can click and watch it all over again. I wish. I'll try and do it tomorrow.
Okay. So are you? Yeah. Okay. Where are you going to send? Where can where do I get it? Are you
on my own page? It's on my own page. I think so. And there is a section.
So how do I access your page?
I think for me, I don't know. I'm not a full staff, but I think they should be able to let you know how you guys can access me. Because apart from the fact that, let me see, I'm trying to get something. Okay, my own page. I don't know how you guys will go to get it. Whether you on the e-learning platform, there's a way you look for your e-facilitator courses and you click something like that would likely
Yes.
come up. Good. Then on that platform, on that page,
Okay.
you will see the online facilitation section recording. So that's where all the recording that we've done, you can now click on it and sit down and watch. Hello.
Okay.
Then there was.
All right. Thank you very much. Is it?
There is a discussion forum that I asked question and nobody has replied. That was based on the last week class. Where we look at the food chain. We have to look at the food chain and the food web. And I gave them a question that you should just describe a simple food chain that you can note or that is found in your locality. And nobody has responded to the question. So maybe you can look at that at the course page. Yeah, the course page. I think you click on the course page. That's where you see my detail.
Okay. Okay. I will assess it there. Sorry, sir. This lecture is going to be on every Tuesday, is it?
Every
Tuesday
Tuesday,
this time?
Yes, 7 to 8.
7 to 8. Okay. Okay. No problem. I pray the network will be stable. I will try because network here in Lagos at times is better, at times, especially this period. It's always very somehow. So, yeah. But we'll try. It's only the network that's a challenge now.
No wala.
We're going to overcome it.
It's a pleasure having you today,
so
sir.
Thank you very much, sir. God bless you, sir.
And you too. Thank you. Bye.
Yes. All right, sir. All right, sir. Have a wonderful night, sir.
And you too. Thanks.